In this lesson, we will create a sieve of Eratosthenes and understand the reasoning behind why it can be used to determine prime and composite numbers. To understand this lesson, students need to draw on their knowledge of the terms factors and multiples. Students will remember from previous lessons, a factor is a number that is multiplied by another number to yield a product or multiple. A multiple is another name for the product of two factors. Now, what is a sieve of Eratosthenes? A sieve is like a strainer. It is used for separating wanted elements from unwanted elements. In this case, we want to identify or separate the prime numbers from the composite numbers. A Greek mathematician named Eratosthenes is credited with developing an easy way to do this. Now, you're probably wondering what prime and composite numbers are. Well, a prime number is a number with exactly two factors, 1 and itself. An example would be 7 because the only factors of 7 are 1 and 7. A composite number is a number that has 3 or more factors, such as 12. 12 is composite because its factors include 1, 2, 3, 4, 6, and 12. To create this sieve, we begin with a hundreds chart. We are going to search for all the prime numbers. If a number is not prime, it is composite. Let's begin with the number 1. Is this prime? By definition, 1 is not a prime number. Remember, a prime number has exactly two factors. However, 1 has only one factor, 1. So this is going to be our odd man out, and we are not going to do anything with this number. Next, look at the number 2. Is it prime? I know that it is prime because it only has two factors, 1 and 2. Now I know from our previous lesson that all multiples of 2 will be composite because they will have 2 as one of the factors. So they will have at least 3 factors, 1 itself and 2. So let's shade all multiples of 2 a different color to indicate they are composite. Now we just move to the next number on our chart, 3. 3 is prime because its only factors are 1 and itself, so let's mark it as prime. Now using the same reasoning as we did before, we will shade in all multiples of 3 as composite because we already know that 3 is one of the factors in addition to 1 in itself. We are ready to look for the next prime number. You will notice 4 is already shaded as composite, so we will move on to 5. 5 is a prime number, and we will mark it as such. You will want to have your child continue to explain each time how they know that this is prime. This discussion will help them to learn the vocabulary and its meaning. Next, we need to mark all multiples of 5 as composite. Which is the next prime number on our chart? I can see that 6 is already marked as composite, so 7 would be the next prime factor. Now I will mark off all of the multiples of 7 as composite. There are still many numbers left on our chart that have not been marked. Are they all prime? Ask your child if they think any may be composite and why. You will want to guide their thinking and help them reason through this question. Once your child has identified all the prime numbers, discuss patterns they see in prime and composite numbers. In this lesson, we created a sieve of Eratosthenes to find prime and composite numbers. We met this objective by using previous knowledge of multiples and factors to understand how this tool works and looked for patterns within prime and composite numbers.